Hello.
Hey, hello. Am I audible?
Good. How are you?
Yeah, I'm good. I'm good. I'm good. Cool. Awesome. So let's start with the coding questions. Like we'll spend like 45 minutes on coding.
Okay.
Like last 10-15 minutes on the feedback.
Okay. Sounds good.
Sure. I'm just testing the question. Yeah. So basically, you have two strings, S and T, of length M and N respectively. You have to return the minimum window substring of a S such that every character in T, including duplicates, is also included in this window. If there are no such substrings, return the empty string. So if you look at example 1, ABC is, you can also have ABC in the substring, right? This
Mm-hmm.
window also has A, B, and C, and this substring also has A, B, and C. But the letter one is smaller, that's why it's a part of
Mm-hmm.
our code.
Okay. Okay. Um. So I just want to ask a couple of questions to clarify. So in the examples, they're capital letters and lowercase letters. Are these the only kind of characters that can be in the string, or could the string have like punctuation, like exclamation points, periods, etc., that kind of stuff?
That's a good question. Let's assume that it just has capital and small letters.
Okay, so capital and the lowercase. Um, okay. And also, can either of the strings be empty? S and T.
Yes, yeah. In that case, output should be empty.
String can be empty. Okay, and what would be the max size of the two strings?
10 to the power 5.
Sorry, could you say that again?
10 to the power 5.
10 to the power 5. Okay. Um, okay, and so the goal is we want to find so that's every character in T. Okay, is included in the window. Okay. Okay. Okay, I think I understand. Um, so I guess how I'd want to approach this, kind of like the question says, we want to have a window to keep track of when all the characters are in our window. So first things first, we would have to know the characters we're looking for.
Mm-hmm.
So what we want to do is count the occurrence of every character in T. So
Mm-hmm.
we could do something like that maybe with a hash map, and we would
Mm-hmm.
say in this example, for example, there's one A, there's one B, and there's one C. And so once we have that information,
Mm-hmm.
um, we can start counting. We can start looking for our window in our main string, right?
Mm-hmm.
So I'm just gonna take this down here. Um, so this is our main string, right? So what we want to do is we can have a pointer. And so what we'll do is we'll have two pointers. So we can say like a first pointer and a second pointer. Um, and basically what we want to do is for every time we see a character in T in our little hash map over here, we should move our second pointer up and start looking for the next character. So like for example, A to start is in our map, right? So we have an A, so we would push this pointer up, and because we've counted an A, we should keep track of the characters we use. So since we use an A, we can decrease this down and say we don't need any more A's in our window. So then we should keep looking. So D is not in our window. So we'll keep looking O is not in our window. B's, yeah, so then we move a pointer up again, and then we say B is in our window. So what we can do is we can use a B, and we can decrease the number of B's we've used, and we should keep looking. So we keep going. E is not in our map, so we're gonna keep going, and then now we've got a C. C is in our map, so we'll decrease it. And then once we see that we've used all the characters in our map, the 3 characters, what we can do is we can save the size of our window, because it's possible like there's a smaller window. So I think this the pointers, the first pointer is at index 0, and the second pointer is at 0, 1, 2, 3, 4, 5 at index 5, which would give us a size of 6 characters. So we could have some min to keep track of our minimum window, and we'd say the minimum size is 6. And the reason why I would also take note of where the pointers are is because we're not returning the length of the minimum window. We're actually turning the actual substring. So we're going to need to know where the substring starts and ends to return it. So I would keep track of that. And then I guess the next thing to do would be keep pushing our second pointer up, looking to see if we can get another one of these characters. So we would, or actually, sorry, we would want to push up the front pointer, yeah, because we used these first 2 characters, so we can push the first pointer up and say, okay, now we're no longer using an A, so we should actually put this back and say that we have an A that we're looking for now. And every time we move a pointer, we'll check, right? Like, is our map empty? Have we used all the characters? Obviously, right now we haven't. So what we'll do is we'll keep searching for another A to see if we can find one. So we'll push up the pointer. There's no O in our map. We'll push up the pointer. We're at a B. So we've used up the B, so that's not gonna help us. And then we push our pointer again. And since B now is no longer in our window, we have to put B back in our map, right? Because we need to find another B again to make sure we have the right window substring. So we'll keep looking. We'll push our pointer up again, keep looking, and then now we're at C. And then once the first pointer is equal to the second pointer, we should start moving our second pointer again, looking in our window again. So we'll put this back because we basically need to look for every single character again, and then we'll push both of these pointers up, because we're no longer using a C, and we're no longer and the S. We're gonna move the S now to search for characters. So we would keep going. We would push S. The D is not in our map. We push S. E is not in our map. We push S. Okay, B is in our map. So we'll take away B from the map, and we'll keep looking. We'll push up A is in our map, so we'll take A away from our map. That would be 0. And then we'll keep going. We'll push S above again, and then N is not in our map, so we keep going. We push S again. We're at C, so we can take C away. C is in our map. And then what we'll do is we'll push this up one more time, right? And then basically we would say, okay, we found another substring. So we want to check, is this smaller than the other substring we already found? And in this case, I think the size is bigger, 3, 7. Yeah, it looks like 7 letters. So we would just keep our minimum the same. And then the next step is to try to decrease the size of our window and see if we can find a smaller one. So now we're going to come back to this first pointer and push it up. O wasn't in our map, so we don't need to do anything. So now, and every time we'll readjust the size. Every time we'll check, okay, have we still used all the letters? Yeah. Okay, what's the size? The size is now 6, so it's the same. It's not going to change. So we'll push the first again. Now this time we still use all the letters, and the size is now 5. So we can actually say the minimum is 5, and we'll say that the first pointer, I think this is 2, 3, 4, 5, 6, 7, 8. This would be index 8, and then we would save the last pointer, which I think is going to be 9, 10, 11, 12, 13. So it'll be 13. and then we continue doing the same thing because we want to go through every possible window substring. So we push F up again. We still have used every character, and we check the size. Now the size is 4. So now we got to resave our pointers. So I believe this would be 9, and the last one is still 13. That hasn't changed. And then we'll push up our pointer again. So now we've gotten rid of a B, so we put the B back, there's 1, and now we're not going to adjust the size because we're missing a character. And then we keep going until our first string meets our second string. So we've lost an A, we've got to put an A back, and then we push our pointer up again, and there was no N, so we're fine. Then we push our pointer up again one more time, we put C back, and then now both pointers have passed the string, so we've checked every possible window substring, and this is our smallest. So now that we have these indexes, we can just return the substring at these indexes. So that I think is one way we can do it. I think if we think about the space complexity, we're going to need to have O of n space where we can say n is the number of characters in T, because we're going to have to keep track of every character in T in some sort of math. And then if we think about the time complexity, looking up in the map is going to be constant time, so that's fine. And then as we iterate over the string S, we're moving 2 pointers, but we're never reiterating over the same characters multiple times. We're just keeping a sliding window. So we can say that the time complexity of to iterate over the T string, we can call it O of M, where M is the number of characters in T, because we have to go through every character in T at least once. So I think O of M time and O of N space is the sufficient solution. So I think I'm going to go ahead and code it.
Basically, let's say like if there are multiple A in between, how will your sliding window take care of it? Will it go in negative if there are like 2 A's?
So if there was 2 A's, so what would happen is let's say this was, we had something like this, whatever, A, B, C, D, and we have only 1 A, right? So we have our first, our second, so we would push our second, we have 0, and then now if there's another A, essentially like it's almost as if we don't have an A, so we're going to skip over it. Basically, we're going to push up, and we're not going to change. Oh, should we go negative? Let's see. If we go negative, let's say we call that -1, and then we keep looking. We go up. We have a B, that's 0. We go one more time. We have a C, that's 0. So in this case, this is a valid window because it has the 3 characters. So I think this size would be, I don't know, we call that 4. Yeah, 4 characters. But then now we have to push our first pointer up, right? Because we found a sufficient window. So if we push this up, we would put the A back, which would make it 0, and then it would still technically be valid because these are all 0 or less. So, and then the window substring would be 3. So yeah, basically if we have duplicate characters, we can go into the negatives because we'll count them later. We'll count them in the window at a later time. Like in this example, we have the first window where we include both, which is valid, and then we count the smaller window. So yeah, if we have duplicates, we'll put our map values into the negatives.
Understood. Cool. Yeah.
Okay.
Let's try
Okay,
the code.
so yeah, I'll do it. So we're returning a string, right? So let's say public string. The goal is to, I'll say, find min window substring. And it's going to take a string. We called it, there was an S, and the other string it took, we called it T, right? So, yeah. So, you want me to include a class as well, or just the function fine?
Just function is fine.
Okay. So yeah, so first things first, we said the strings can be empty, right? So we'd want to check for that edge case. So if if s is empty, so if s dot length equals 0, it would not be possible, right? Because there's no characters. Return the empty string if there is no such substring. I guess technically, if both are empty, then we would still turn empty. Yeah. So if s is empty, we'll return an empty string. And I guess if t is also empty, we'll return an empty string. And t dot length 0 will return an empty string. And then in the case where if there's characters in S, and there's no characters in T, I guess technically we would return all of S, right? Like if we had ABC and then T was just an empty string, then would that technically the entire string is valid as part of the window, or it would be there's no substring. Yeah, I think yeah, that would be there's no substring. So I think we can say if T, we'll just say or here actually. If either one of these is empty, we'll return empty string. Okay, so that handles that edge case. And then what we want to do now is we need to count all the characters in T, right? So count chars in T. So what we'll do is we can use a hash map, like I was saying, or we can also try to use an array representation of a hash map, which would just be a bit better because we can avoid collisions if we use an array representation. I think for now I'll do a hash map, and then later if we have time I'll switch to the array representation. So what we'll do is first we're gonna need a hash map. So we'll say hash map. It's gonna be a character as the key and an integer as the value. Integer, and we'll call it chars in T. And then what we'll say is be equal to new hash map, right? And then that's the hash map we're going to need. We're also going to need to keep track of a minimum, so we'll say min window, and we'll set this to let's say the min, the largest way the window could technically be is the whole string, so we'll say s dot length. And then what else do we need? We are keeping track. We need pointers, so we're going to say we'll say int first and equals 0, and we'll say second equals 0. So I think these are all the variables we need. So now let's put everything in a hash map. So we'll say for char c and t dot to char array for every character in T. What we're going to do is we're going to say chars in T dot put if absent. So we'll put in the character C, and we'll just put in 0. And then the next line we'll say chars in T dot put. We'll say the chars in T dot get C plus 1, and we got to put the character back in. So we're just putting it with a value of 1. This would just put the character with 0, and then we just add 1 to the character because we have to count it once. And then so this will count all our characters in T. So that's all good. And then the next step is to try to find our window, right? So we'll do a while loop. We'll say while s, s is the longer one. So we'll say while, and first is the one we want to say. While first is less than s dot length, we'll start. Um, and we'll say, so while that's the case, we want to find our window. So what we'll do is we'll say if the if the second um, if second dot sorry if s dot char at second, the map contains it. If chars in t dot contains s dot char at second, um, then what we'll do is we will say uh, chars in t dot put. We'll just update this. So we'll say s dot char at second, and then we'll just say chars in t dot get s dot char at second minus one. So we're just decreasing it. Yeah, so we're just decreasing it. And then that would update our value. And then so once we've done that, what we'd want to say is we're gonna have to do second plus plus. We're gonna have to push our pointer up. And then we also want to know when we found our window, right? When we've actually found our window. So yeah. Actually, what I might I think it'll be a little more simple. I might actually just actually, I don't think that would work. I was gonna suggest changing all the characters to just be lower and then use the array representation, but um, I don't think that would work because if we have like
Mm-hmm.
capital A and lowercase a, it
Right.
would mess it up. Yeah, so I'm not gonna do that. So okay, we'll just stick with the math. I'm just thinking because I need to know when I've got my window, right. I need to know when
Mm-hmm.
I found my window so I can check the size, save the size.
Mm-hmm.
So there needs to be a way to essentially when hash map, all the values in the hash map are zero.
Mm-hmm.
Um, I don't want to have to iterate through check every value in the hash map to see if that's zero. That'll take too much time. Um,
Mm-hmm.
so I'm thinking maybe what I'll do is I'll have some, we'll call it uh, chars bound, and basically set this to zero. And basically, every time I find a character, I'll increase this. So like in this case, we found a character. So what I'll do is I'll say chars bound plus plus. So now and then basically once, so, as long as the number of characters I found is greater than or equal to the length of t, then I've got my valid window. Um, so actually, I don't think that's gonna work because what if we have two B's? We'll have yeah, if we have two B's and a C, we'll say we have three characters found, even though we don't have them all found. Um, uh, yeah, that's gonna be a problem. Uh, I guess what I'll say is I'll say yeah. What I'll do is if say if s dot char at second, or what am I doing? If if chars in t dot get s dot char at second. So basically, um, if if oh my gosh, I think I've going crazy with the brackets. Chars dot in t dot get s dot char at second. Yeah, if that is, so long as it's greater than or equal to 0, and I haven't gone into negatives, then I'll say I found a character. So I'll say found chars chars found plus plus. Yeah, I think that's good. Chars in docket. I think I have too many brackets. Yeah, if if that is greater than or equal to 0, after I've just taken a character away, I'll increase it. So it'll be chars found plus plus, and then we'll say second plus plus, and then the other cases when we start, we want to say if chars found equals t dot length. So we found all the characters. What we want to do is we want to save the size. So we want to say min window equals math dot min of the current min window and the difference between my second pointer and my first pointer plus 1 because we're 0 indexed. So yeah, so that will save the size of our window. And then after we've saved the size of our window, we have to also save the indexes that we're going to be using later. So I'll actually have one more variable to keep track of the indexes. We'll just say window indexes equals a new integer of size 2. And we'll just say window indexes at 0 equals first, and window indexes at 1 equals second, so that I know what substring to grab later. And then the last thing we want to do is we want to move our first up, first plus plus, because we want to see if there's a smaller window. So yeah, that I think is good. We check if we found the character, we push the second up, and then yeah, I think that's good. So then at the end of our loop, once we're done going through the first, or no, actually, chars is found. If chars equals, and then we go. I'm just thinking if we have a case where we have the window and there's multiple characters we need to go through. Like in this case, if we have a window, something like this, and we're trying to see if there's a smaller window, I should make this a while loop, or if that doesn't matter, because I think actually this can be this can be um, an else if. And also, I forgot to add back the character when we push it up. So before we push it up, we'll say chars in t dot put. We will put in the we'll put back the character s dot char.
So will you push back the character which was not originally present in T also?
Pardon?
So will you push back the characters which was not originally part of T also?
Oh yeah, you're right. I see. So we'll say what we'll do is we'll have an if thing. We'll say if chars in t uh dot contains key s dot char at first. So if it was actually in it, then we can add it back. So we'll say chars in t dot put. We'll put s dot char at first, and we'll say s dot. We'll say chars in t dot get s dot char at first plus 1. So that'll put that back only if it's one of the keys that's actually in T. We'll put it back, and then we'll push the pointer up. Yeah, so I think that works, and then we'll just keep doing that. Basically, it's also if we still have a valid window next time, we'll keep pushing up the first pointer until we no longer have a valid window, and then we'll go back to searching through seconds. I think that makes sense. And then at the end of a while loop, I think we're missing. Oh no, it's still here. The last brace. So then what we want to do is we want to return the string, the substring, right? So we can just use Java's. Actually, we need to check one thing. We need to check in the case where maybe we just never found the window, right? It never existed. So we'll know the window never existed. What we'll do is we'll change this to +1. So that way, because like I said, there's a possibility the entire S string could be the window if S and T are equal to each other. So then what we can just do is we'll say if min window equals S dot length +1. That means we never updated the value of min window, which means we never found one. So we'll just return the empty braces. Otherwise, we can just return, we want to return a substring, right? So we can just use Java substring function. We can say s dot substring, and we need to pass in, we'll pass in the first, we'll say new indexes, window indexes at 0, and we'll pass in window indexes at 1, and I think we should do +1 because of the way the substring works. It doesn't take the last character. The second parameter is not inclusive, so I think that makes sense. So I'm just going to run through an example just to make sure everything works fine. I can just do something similar to this. I'm just gonna add some duplicates, and maybe I'll shorten the length a bit. So we'll have something like A, B. We can even throw in more case letters too. I think this is good enough for me. And then we'll have T. Maybe we can say T is something like we'll say A. Let's do A, B, C like this, and we'll put in one more C just to have a duplicate. Okay. So yeah, let's run through this. So first things first, let's declare all our variables. So we'll generate a new hash map. I'm just going to put map for short to make it simple. And then the next thing we have a min window is going to be the length of S plus 1. So the length of this is 4, 7. So min window is going to be 8. And then what else do we do here? We have a first and second equal to 0. So these are pointers. So I'm actually going to put them right here. And then we'll say chars found was 0. And we'll have window indexes right now are just 0, 0. That's how they're initialized. And then the correct answer would be ABC for this. So I'm just going to say result is ABC, and we want to make sure we get that. Okay, so we have all our variables declared. First thing is put everything in a hash map. So for every character in T, we're going to put in the map the character. So we got A, and then nothing, and then the next line is get A, and then add 1, and then put A back with put a new thing back, A, with 1 greater than what it currently is. So this is going to be 1, and then B is going to be 1 as well, and C is going to be 1. So we built our map. Now, while first is less than the length of S. So we're going to say if chars found is 0. If chars found equals the length of T, no, because it's 3, it's 0. So they're not the same. So we're going to skip all this and we're going to go to the else. We're going to say if the chars in T dot contains S dot char at second is A, the map contains it. So what we're going to do is we're going to put in the map A, but we're going to put 1 less than its current value. So A is going to become 0. And then the next thing we're going to do is we're going to say if chars in T dot get A, so if the value at second, which is A, is greater than or equal to 0, which it is, it's equal to 0, we will increase our chars found. So we have 1 character found. Cool. And then we say second plus plus, and I think yeah, I made a mistake. This second should be in this else if, because we don't want to push the second up if we've only done stuff with the first one. So yeah, we'll push the second up, and now we're on to the next character. So the next step is same thing. Chars found is 1, the length is 3, so we're not going to run this. We're going to go to the else if. So we're going to say if the chars in T contains s dot char at second. So it does contain the map does contain A. So what we're going to do is we're going to put in A 1 less than what it is currently. So it's going to become a -1. And then we're going to say if A's value is greater than or equal to 0. Well, it's not, so we're not going to increase our chars found. So we're simply going to say second plus plus. And then just for time's sake, same thing's going to happen, exact same thing. We're just going to push past A, and this is going to be -2. And then now we're on B, right? So B is, and also actually, I think I was too ahead of myself. I think this is supposed to be outside, because if we have like a random letter, like we have like a K here, we need to push up second, otherwise the loop will go endlessly. So that's why we have to have the second plus plus outside. Both of these if statements would be false on the K, and then we push the pointer up. Yeah, so it should be like this. And then now we'll check again. Chars found is still 1. The length of T is 3, so we're not going to run this. We're going to go to the else if. So we're going to say, is the character at second, which is B, does the map contain a lowercase b? Yes, it does. So now we're going to say, put in the map 1 less than the current value of B. So it's going to be, become a 0. And then we're going to say, is the value at B, is it greater than or equal to 0? Yes, it is. So we're going to increase our chars found by 1. It's going to be 2. We're going to push the second one up, second plus plus. And we're going to be on a C. And now we're going to say, same thing, is chars found equal to the length? No, 2 is not equal to 3. So we go to this else if. We're going to say, is the value, does the map contain the character at second, which is a C? Yes, it contains a C. So we're going to say, put in the map the same character C, but 1 less than its current value. So it's going to become a 0. And then we're going to say, is the value at C greater than or equal to 0? Yes, it is. So we're going to increase chars found by 1. So it's going to be 3. And then we're going to push the pointer up. So we're going to go to here. And then now if chars found equals T dot length, it does, they're equal. So we're going to say the minimum window is second minus first plus 1. I think this might be a mistake. So if we say first, there's how many characters? 1, 2, 3, 4, 5, 6 characters. But I think I have here second minus first is going to be 7 minus 0, 0, 1, 2, 3, 4, 5, 6, and there's 6 characters. So let me get rid of this plus 1 actually. The way I'm doing this actually should keep it second minus first. So this would be 6 minus 0, which would give us 6. And that is smaller than 8, so our new min window is 6. And then we'll save these indexes, right? So index is first. Where did I put these? Here. So first is a 0, and second we said was 6. So we're going to save these. And then we are going to say, does the map contain, does the map at first, which is an A, this capital A here, does the map contain it? Yes, it does. So what we're going to do is we're going to add, we're going to put back in the map in A with 1 more than its current value. So this is going to become -1. And then we're going to push first up and come here. And then we're going to continue with our wild, yeah, this is a problem because second, we push second up. We don't want to push second up. So we want to push second up. We can say second plus plus here, and then maybe if we just say else second plus plus, then in this case, if both of these aren't true, we still push second up. In this case, second is, in this case, we just run this if statement. These two else's don't run, so second will stay the same. So I think that's the appropriate fix. Um, so yeah, now we check again basically, and chars found is equal. Do I ever change the value of chars found? No. Okay, that's that's another problem because we need to change the value of chars found. So what I'll do is once we put it back, we'll say if chars in t dot get s dot char at first if this equals if it's greater than or equal to or no, if it equals 1. If we just
Mm-hmm.
if it's now greater than 0, that means our found chars, we don't have all the characters we need anymore. So we'll say found chars
Understood.
minus minus. So in this case, our found chars it won't change because the value is -1, so we still found 3 characters, so that's good. So the next step is, yeah, and the loop's going to continue. So now chars found is still 3, the length of t is still 3, so we're going to grab the new minimum window. So second minus first in this case is 1 minus 6, which is 5.
Mm-hmm.
And so the window is going to be 5, and we're going to update this to be 1 and 6. And
Mm-hmm.
then we're going to say we have to increase this a by 1. So we'll say the a is now 0.
Mm-hmm.
And then we're going to say, is the value at a equal to 1? No, it's not. So our found char is going to stay the same. And we push the first pointer up. So this is going to come
Mm-hmm.
here now. And then we're going to go back to the start of the loop because these two else's aren't going to run. And then chars found is 3, the length of t is 3. So then we're going to grab the new min window, which is going to be 6 minus 2, which is 4. And then we're going to say 2 and 6. And then we're going to say, is the value at first in the map? Yes, it is. A is in the map. So we're going to say put back in the map one more value than the current value of A. So this is going to be 1. And then we're going to say if the character at A is 1, then we'll say found chars minus minus, which it is. So we're going to decrease found chars to 2. Oh, I called it found chars. It's chars found. Chars found. And then we're going to push the first up like this. And then we're going to, these two else's aren't going to run. We're going to restart the loop. Now we're going to say 2 is not equal to 3. So we're not going to run this. We're going to do this else if. We're going to say, is the current character, I think that's a K, yeah, is the current character K in the map? No, it's not. So we're going to go to this else, and we're just going to push the second pointer up. Yeah, we're going to push the second pointer up. Wait. Our minimum window, yeah, oh, that's right, actually. We're going to push this, I forgot I changed the problem. We're going to push the second pointer up. Um, so Oh, my bad. No, I was looking at first, not second. We're actually looking at the second. So we're gonna say, is the C in the map? It is. So we're gonna put 1 less than the current value of C, which is 0. So it's gonna become -1. And then we're gonna say if the value is greater than or equal to 0, the character found is we're going to increase the value of the character found, but it's less than 0, so we're not going to do that. And we're going to push our second up. So we're going to say second plus plus. So we're going to push the S up, and then we're going to get to B. And then at capital B, we're going to say is chars found equal to the length of T? No, it's not. 2 is not equal to 3, so we're going to come to this else if. Is B in the map, capital B? No, it's not. So we're going to go to this else. We're going to push second up. And then actually what's going to happen here is we would actually get an index out of bounds at this line because there's no more characters. Like we would check this, this would be true, so we check this else, but second's
Mm-hmm.
out of bounds, one error. So we have to fix that. So if this is the case, I think if second is out of bounds, yeah, I think we can actually do when the second one
Mm-hmm.
less than first because based on how our window
Right.
works, if we had ABC in here, our window would still be valid, so we would never get to that else if. So yeah,
Right.
once that is done, we can end the loop, and then the loop would be done, and then we'd say, is the min window equal to the s dot length plus one? No, it's not. So
Mm-hmm.
then we'll just return the substring windows at index 0, which is 2, and windows at index 6 plus 1, which is 7. So I just want to make sure that's right. 2 0 0 1 2. So we'd return A, and then
Mm-hmm.
3 4 5. So we don't need the plus 1 actually. We should just keep it to this. So it would be 2 and 6. And like I said, the substring, the last value is not inclusive. So
Mm-hmm.
it would end up returning that substring of A, K, B, C. So yeah, I think I'm sufficient. I'm satisfied with the solution. And like I said, the time complexity is O of n, where n is the number of characters in S, and the space complexity can be O of m, where m is the number of characters in T.
Understood. Yeah, cool. I think, yeah, this should work. So I'm just trying to go through the code once. Yeah. And give me just a minute or two. Hmm. Sure, cool. I think, yeah, this should work. Let's move to the feedback part of it. I think, like, yeah, you really started well by asking like a really good clarification question, like whether string can contain the special characters, or like can string be empty, any of the string can be empty, what would the output in that case, right?
Mm-hmm.
Yeah, we also asked like what would be the maximum length of a string, so that like we can have a bound on the time complexity of algorithm. Um, so yeah, I think like that's a good thing. Like most of the I find most of the candidates missing on asking these questions about what character can be involved in a string, right? So good that you did it. And you also come up with like sliding window approach, like because that's what will be used. You were right to identify the pattern in this, and you also handle like well the edge cases where either of the string can be empty in your when we started writing code. And
Mm-hmm.
yeah, you also debug yourself the issues in your code and rectify it, right? So I
Mm-hmm.
think like you click on all the checkboxes. The only thing which could have been improved is there could have been an easier way to write this code. There could have been like rather than having just one while loop within inside it, you could have like things like keep iterating unless you found a match, or keep iterating unless you found the first character which will bring T out of it. So yeah, but I think like yeah, saying is easier, but like you're trying to solving this problem first time, considering that thing, like it's a good code. So yeah, yeah, I think yeah, you did really well. Only thing could happen is like you could have done the implementation part a little faster, right?
Mm-hmm.
So basically, I think like 5-10 minutes faster would have been good thing, because I was planning to ask a follow-up question on this,
Mm-hmm.
like just the approach of follow-up question, not the code. So I think like yeah, overall on the speed side, there was like a bit the speed was on a bit on slower side, mostly in the
Okay.
implementation part, and also while explaining it, you could have explained in more brief, like rather than going with the example and trying. Yeah,
Okay.
so basically, we could have saved like 5 to 10 minutes in between and had some time for the follow-up question.
Okay.
So
Okay.
that's the only issue I'm having. Like I have from this thing, but overall, it was a good thing. Like I think like you have a good framework. You clarify the question, you share the approach, you identify the complexity by yourself, and then only you went on coding it. So yeah, I think like in terms of your structure or approach, I don't have any recommendation. But maybe like a bit time check would could be useful, like making sure that like
Okay.
you have some time for follow up or something at the end of interview.
Uh-huh.
So do you
So
have?
so do you think then, just for when before I start coding and I'm explaining kind of my thought process, um, so you don't think like running through an example is necessary as long as I kind of just talk through what I'm gonna do?
I think yeah. Approach wise, it's not necessary to
Okay.
talk through with example. That could save some time.
Okay.
Yeah, but like what you did once you have done with the code, running through example, that makes sense because there
Okay.
you discover the issues with the code. So yeah, but like running your approach through example at the beginning, um, that was like that could have been avoided. Yeah.
Okay.
But yeah,
Okay.
but
Okay.
sometimes
Cool.
it might happen that approach is tricky. And interviewer might
Hmm.
ask you to go through like, can you help me how it will go work with this example? At that time, like you
Oh.
might want you don't have option but to go through it. But yeah,
Okay. Okay.
cool. Do you have
Okay.
any specific interviews lined up?
Yeah, I have on
Mm-hmm.
Wednesday my interview with Google, so I've just been practicing.
Understood, understood. Cool, awesome. Is it for L3 or L4?
For new grad, I think that's L3, right?
Right, right, right. Cool. I think, yeah, for Google, my suggestion would be like to also have some time. Is it just a coding interview or all the looks, all the interviews on that day?
All of them in one day. I have three technicals and one behavioral.
Yeah, my suggestion would be like to also have some examples written on a document so that you get in a structure of like star format, situation, task, action, and result, right?
Mhm.
And
Mhm.
like have some numbers backing those things like how much time it took for your project, how many people were in it, things like that.
Okay.
Cool.
Okay.
All the best. All the best for your actual interview. Yeah. See.
Yeah. Thank you. Thank you so much for taking the time to do this. Appreciate it.
Cool. I think yeah, you need to write a feedback after this. So please do that.
Yeah. Yeah.
Yeah. Thank you. Bye.
Thank you. Have a good day.